Welcome to lesson 3.1. In this lesson, we're going to learn a bunch of trig identities. These are basically more equations that you need to memorize. So like we've done the quotient identities so far, we've done the reciprocal identities and the Pythagorean identities, we're going to add more to those today. So we're going to start off with the even-odd identities. Now, basically how I memorize the even-odd identities is sine and then its pair, which is cosecant, and then tangent and its pair, cotangent, both have negatives that just move out in front. So if you have a negative inside the sine, cosecant, tangent, cotangent, you can move it out in front. That's the even-odd identity. However, for cosine and its pair secant, that negative disappears. So there's no negative. If you try to take it out in front, it just goes away. So those are our even-odd identities. Now we're going to use those to simplify some problems. So let's start with this one first. First thing I see is that in this second set of parentheses, I have sine of negative x. Now remember, for sine, we can take that negative outside and make it like that. Now, this is difference of squares. I can FOIL distribute this together. 1 times 1 is 1. 1 minus sine. Sine times 1 is a positive sine. And sine times negative sine is negative sine squared. Those cancel. I get 1 minus sine squared of x, which we know from our Pythagorean identities is cosine squared of x. So there we go. So that's an example of how we use these even-odd identities. So what I would like you to do is try this one on your own. So start by changing those negatives. This is cosecant and tangent, so those negatives will move outside. Then use your reciprocal and quotient identities to simplify this down as much as you can. Come back and check your work. Let's check your work. So I brought the negatives outside first. A negative times a negative makes them positive. Then I changed cosecant to 1 over sine, tangent to sine over cosine. I notice my sines cancel. And I get 1 over cosine, which is secant. Let's try one more of these. So let's try C. I'm going to get you started on this one. This time we have cosine of negative x. Remember, cosine is one of the two where the negative just goes away. So we have this. Now, to combine these, you're going to need to find a common denominator. So now our denominator is common and we can simplify the numerator. So with that beginning hint, I'd like you to pause the video right here and try to finish simplifying this one out by multiplying everything you can, simplifying, and see how simple it can go. Let's check your work. So I multiplied the numerators together, I got 1 minus cosine. Multiplied these numerators together, got 1 plus cosine. I combined those two numerators over my common denominator, which I FOILed. Ended up with 2 over 1 minus cosine squared. We know from the Pythagorean identities that 1 minus cosine squared is sine squared. And I could bring this sine squared up to make it 2 cosecant squared. So let's do one last example with these even-odd identities. And that is, instead of just simplifying something, let's go back to verifying identities. So remember, on these ones, you can only work on one side at a time. You cannot move things from one side to the other. And typically, we want to work with the most complicated side first and simplify it down. So that would definitely be right here on the left-hand side. Now, before you get started on this one, remember that sine squared of negative theta is exactly the same thing as this. And it will be more helpful in the problem to write it this way instead of this way. And you'll see why as you work through it. Same with cosine. So now that we've got it written like that, let's go ahead and just start you out and then see if you can finish this on your own. So first thing I've got a sine of negative theta, and this is a sine of negative theta. So those will move outside. Then I have a cosine of negative theta and a cosine of negative theta. Those ones will disappear. So now I've got this so far. Now, here's why it's really important that we move that squared outside, so that you remember that when we're squaring this, we square the negative and the sine. So then if I'm squaring this negative, it turns the negative into a positive. So negative sine of theta squared gives me positive sine squared of theta minus cosine squared of theta. So now I've got this. Now you might be inclined to use Pythagorean identity on that. Pythagorean identity only works if they're adding, not subtracting. So we have to do something different on this. So something I want you to see is that even though this looks funny, this is actually difference of squares. It's the same thing if I gave you x squared minus 4 and you factored that as x minus 2 or x plus 2. Or if I gave you x squared minus y squared, that would be x minus y, x plus y. Same thing here. Sine squared minus cosine squared is going to be the same thing as sine of theta minus cosine theta and sine of theta plus cosine theta. And I also noticed that in the denominator they have a negative in common, so I'm going to take that negative out. Now the reason I do all of that is now I notice I have something on top and bottom that's going to cancel, and I'm left with a negative sine of theta minus cosine theta, which if I distribute that negative in, I get negative sine of theta plus cosine of theta, which is the same thing as cosine of theta minus sine of theta, which is what I wanted to get. And there's your trig identity. So those are a few examples using your new even and odd identities. In the next video, we're going to introduce some more identities and practice with those.